Hey guys, welcome back. This is going to be your notes for 3.2 linear functions for Algebra 1. So the first term you're supposed to know, this previous term, whole number, all that is the counting numbers in zero. So 0, 1, 2, 3, 4, 5, 6, 7, all the way up to infinity. No decimals, okay? No decimals, no fractions, just the basically from 0 up on the number line, it's the tick marks. So the whole number is the tick marks on the number line. Now let's go through the rest of these. So linear equation in two variables. So any linear equation can be written in a certain form. And obviously big ideas is making some mistakes right now. So I'll just tell you a linear equation in two variables. It has a lot of stipulations to it. You cannot have x and y to any power other than 1. You cannot have x or y in the denominator. You cannot have x and y multiplied by each other, okay? So really what you're looking for, you're going to have two variables. They can have coefficients, but they can't have exponents, and they can't be anything like square roots, logs, nothing. It's just two typical variables, one, and you can always set one equal to the other. Let's see. Okay, so now we have linear function. Is a function whose graph is a non-vertical line. So be careful. All lines are linear functions except vertical ones, because remember, a vertical line is not a function. It would not pass the vertical line test, okay? Non-linear function. A non-linear function is anything that is not a linear function. So anything whose graph does not have a constant rate of change or whose graph is not a line. And this constant rate of change, we're going to come back to in a little bit. So a solution to a linear equation in two variables. So remember, a solution to an equation is any number that makes an equation true. But now we're going to see that we have an infinite number of possibilities. And I'll get into this more in class, but just think, if you have two numbers that have to equal another number, like x plus y equals 5, there is an infinite number of combinations when you start thinking about negative numbers and decimals that two numbers could add up to make 5. So those pairs are the solutions. And one neat thing you're going to see, if you have a linear equation, those pairs will always fall in a straight line. Discrete domain and discrete range it should have, along with continuous domain and continuous range. Now, we talked about these in 3.1. A discrete domain is a finite domain. All that means is you actually can tell me all the numbers that you plug in. Just like a discrete range, you can actually tell me all the numbers that come out. A continuous domain or a continuous range, that's when you have like a graph or you're talking about a variable such as time, where you would have an infinite number of inputs along with an infinite number of outputs. When you have an infinite number of inputs or outputs, you cannot possibly list all of them. So remember, in 3.1, that's when we were talking about using the less than or equal to signs, and that's how we would describe the domain. So if you go back to 3.1, we talked about list or describe all of the inputs. That's what the domain is. Well, when you can list them, you have a discrete domain. When you have to describe them, that is a continuous domain. And that is our intro for 3.2.